Let's look at climbing stairs problem. You're climbing a staircase, it takes n steps to reach to the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Given n will be a positive integer. For an input of 2, the output is 2. This is because 2 steps can either be reached by climbing 1 step plus another step, or by climbing 2 steps directly. Similarly, for an input of 3, the output is 3. This is because to climb 3 steps, we can either reach 3 steps by climbing 2 steps and then adding 1 to it, or by climbing 1 step and adding 2 to it. 2 steps we know can be reached by climbing 1 plus 1 or 2 directly. So these are 2 ways in total. And climbing 1 step and adding 2 to it is one other way. So in total, 3 steps can be climbed by 2 plus 1, which is 3 ways. Therefore, the generic formula would be n steps can be climbed by knowing how many ways we can climb n minus 1 steps plus how many ways we can climb n minus 2 steps. Clearly then, a bigger problem can be solved by solving smaller subproblems which has the same optimal substructure. Therefore, we can use dynamic programming to solve this problem. So, taking care of edge cases when n is less than or equal to 2, we have, if n is 1, the number of ways to climb 1 step is 1, and if n is 2, the number of ways to climb 2 steps is 2, as we've seen here. Therefore, when n is less than or equal to 2, we can return n itself. And in other cases, we can iterate from 3 up to n, each time caching the number of ways that can be reached and finally returning the cached result at the end of nth iteration. So in order to translate that into code, let's take care of this condition. When n less than or equal to 2, return n. Let's declare 2 variables, 1 step away, where you need to take only 1 step to reach nth step, and 2 steps away, where we need to take 2 steps to reach nth step. And let's declare a result variable, iterating from 3 to n. Result will be the number of ways that can with which we can reach ith step. That would be sum of 1 step away plus 2 steps away. After every iteration, 1 step away would equals 2 steps away, and 2 steps away will equal result. This is because at 3 steps the result will be 1 plus 2, which is 3, and then 1 step away would be equal to 2 steps away, which is 2, because for the 4th step from 2 we would have to take 2 steps away. there will be a difference of 2 steps, and similarly 2 steps away would be equal to result. And finally, after n iterations, the number of ways to reach the nth step would be in the result variable, so we'd return result. Let's go ahead and run this code. Let's pass the given test case. Let's submit. So the time complexity for this solution would be O of n, since we iterate up to the given n. Space complexity is O of 1. Thank you.